Hello everyone. In this short video, I wanted to talk about a couple of considerations when trying to integrate LTE connectivity as part of your WAN uplink strategy when it comes to VeloCloud SD WAN. First of all, what are the reasons for doing it? You might be in an area where the wireless signal is strong enough to give you the option to introduce an extra circuit into the mix, whatever that is, purely to increase the bandwidth or to provide redundancy. Especially in remote locations, you might not actually be able to bring two redundant circuits. And when I mean redundant, I mean not two different ISPs, one reselling services from the other, because in that case you might actually end up on the same aggregation device, or even worse, on the same line card up in the exchange. So in that case, a couple of 4G links might be sufficient to give you the throughput needed. And the easiest way to integrate LTE is actually having a dedicated router for it and then using one of the WAN ports to terminate it. As far as this device is concerned, well, that's just another internet link. It can get to the gateways, it can get online, so it doesn't really care or even understand that the link it's using is wireless as opposed to wired. This tends to be the most expensive but also the most performant solution, because if you want better throughput, you probably want to get the antenna outside the building and even go all the way to use directional antennas. Then you have the option to stretch an Ethernet cable all the way to the location of the edge. Now, if you really have a really good signal in the part of the building where the edge is, you can then look at a couple of other options. And first of all is the option of using a cellular dongle that you can insert in USB 1 and USB 2. All our devices, no matter if it's the small branch 510 or the big data center 3000 series, support two USB interfaces, and you can even use them as active. We have a list of approved vendors that we have tested, and you can find them in the link below. Now, if you don't want to bother with dongles, and some people do have different issues with them, especially when it comes to interoperability and understanding why the setup is not working, because again, we're talking about two different vendors and not being able to see the whole system end to end, and you're deploying this at a branch, you can go with our 510 LTE model, the same one that I have here in front of me. This gives you the ability to actually slot the SIM card directly on the back of the device. The reason for that is because we have built a cellular modem directly in the device itself, and it's based on Cat6 technology. So it gives you theoretical speeds of 300 meg up and 50 meg down. And when I mean theoretical is obviously this assumes a perfect clean environment and the best signal strength, which it's not really a reality any of us live in. So again, signal strength when it comes to LTE is extremely important. If you unscrew the back bit here, you will see two slots. It's a bit confusing because only one of them is being used today, and that is the bottom one. So insert the SIM card with the pins facing up in the bottom slot. There are two different versions for this. So if you're operating in multiple geographies, please also have in mind that we have a version that works across North America and Europe, and another one that works in across Asia. Now, after you have deployed a mixture of wired and wireless links, or have gone wireless altogether, nothing is stopping you inserting a SIM card and putting it on a food truck, for example, you have to decide how you want to use the links. By default, everybody likes to use their links as active because you can use the extra bandwidth, the failover is really fast. But you also have to consider that in a month, the management traffic for the box itself and also the connections it supports with other edges can rack up a considerable bill. we're approximating the data use around 4 to 5 gigs. And if you'd rather not pay for that, you can always put the interface in backup mode. So when the active links go down, this is where the backup interface gets engaged. Some of the reasons that make people not go for that mode is, first of all, it takes a while at failover to redo the whole tunnels and connectivity, and you might even run into surprises and realize that for any sort of reason the tunnels are actually not being built at all. Something that if you left the link on active, you would be able to realize and troubleshoot before things start breaking down. With this in mind, we in the latest version of code 4.0 that is currently being rolled out. I'm making this video end of October 2020. We have this mode called hot standby. So it retains the performance of an active link. So the tunnels are still built, the interface is still up, so you can understand if something goes wrong with it before it needs to take over. But the management traffic is reduced. So now instead of 4 to 5 gigs, we're looking at 300 to 400 meg a month. A great improvement that brings both cost effectiveness and performance into one. With this feature, we also bring something called the minimum active interfaces. So now if you have a couple of wired ports on the back, and then maybe have a USB dongle, you can put it in hot standby mode. And for example, say if one of my 2 wired ports go down, engage the interface, as opposed to wait for all the wired ports to go down before turning this one on. So in summary, these are the 3 main ways you can integrate LTE. Separate router somewhere outside, the most costly but performant, because it allows you to have that flexibility to position the antennas where you want to have the best signal strength, and give you a lot of extra troubleshooting tools. Again, this depends on the vendor itself. USB dongles, a bit cheaper, but also assumes that you have great signal strength where you place the edge. Definitely not in an enclosed cabinet in the center of the building. And the integrated LTE for the smallest branch